Hi everyone, I am Madam Rosmaya. In this video, we are going to discuss one example on Newton's law. A rocket stands vertically on its launching pad. The total mass of the rocket and its fuel before launch is 2.0 times 10 to the power of 3 kg. On ignition, gas is ejected from the rocket at a speed of 2.5 times 10 to the power of 3 meter per second relative to the rocket, and fuel is consumed at 7.6 kg per second. Find the thrust of the rocket and explain why there is an interval between ignition and lift off. So in the question given, we are given a mass 2.0 times 10 to the power of 3 kg, okay, mass of the rocket, and also the speed of the gas ejected is 2.5 times 10 to the power of 3 meter per second, and the 7.6 kg per second, so this is a rate of change of mass, which is dm by dt. So this is all the information given in the question. Okay, from Newton's second law, state that resultant force is directly proportional to the rate of change of momentum. So momentum is mass times velocity. So because v is constant, so we can bring the v in front and leaving dm by dt at the back. So dm by dt is rate of change of mass, where mass is changed by time. So we substitute the value of v, 2.5 times 10 to the power of 3 meter per second, and then the rate of change of mass is 7.6. So the force will be 1.90 times 10 to the power of 4 Newton. Okay, so this is the force upward, or another word is thrust of the rocket. So the upward force, which is thrust of the rocket, calculated here is 1.90 times 10 to the power of 4 newtons. So besides the force, another types of force act on the rocket is the weight of the rocket. So we are going to find the weight of the rocket. So the weight of the rocket is mg. So the initial weight of the rocket before the rocket is consumed, or the fuel is consumed, so we are going to calculate now mg. So it's equals to mass of the rocket, 2.0 times 10 to the power of 3 kg, including the fuel in the rocket before it is consumed, and then the g is 9.81. So the answer is 1.96 times 10 to the power of 4 Newton. So this is the initial weight of the rocket, and we compare the two forces. So we find that the weight is larger than the thrust of the rocket, okay? Which means weight is larger than the upward force. So what happened? This means the rocket cannot lift off yet at the time being. So since the weight is greater than the thrust, the rocket does not lift off from the launching pad. So the ejection of gas from the rocket results in the total weight of the rocket continues to decrease because the fuel is consumed, and when it is consumed, the weight of the rocket will continue to decrease. So when the total weight of the rocket become less than the thrust, the rocket lifts off. So hence there is an interval between ignition and lift off. Okay, that's all for the question. Thank you for watching.